I'm going to walk you through how to back up the EPROM on a Fadal. I guess this works for pretty much any kind of not EPROM, EPROM, the UV flash, UV erasing flash ROM. So the basic principle here is we're going to pull both these chips out. We're going to save the binaries, and then we'll be able to flash them onto a new one. This is mostly just to make backups to make sure if your board gets fried, something gets fried, that these things are kind of hard to replace, hard to find. Sometimes they're not in stock, so I don't know who makes them anymore. Probably nobody. So if you want one, you either have to buy it used or you're out of luck. So this is how I get them off. I just use these little plastic tools. You just have to be very careful not to bend the pins. So just gently kind of pry them up. And they'll pop up like that. And there's two on each board. They're labeled even and odd. And they kind of, it's interesting, they kind of like go back and forth, the memory addresses on these. So you need both of them, obviously, and they need to be in the right spot. So there we go. That guy's out. None of the pins are bent. Everything's in good shape here. So we're gonna pull out the even one, the U15. There's also an odd U18. We'll need both of these. So the next step is to come over to our little programmer. So at the programmer, there's a notch on the end of the chip. Right there, that's like the indexing mark. You'll notice on this, it shows you that the notch goes this way. So we're gonna take this chip, line it up with the first slot there, and then we're gonna lock it down. And that's it, it's connected.
Okay, so now I'm going to show you how to capture the binary file from the chip we just put in. So the first thing we're going to do is go to Select ICs, search and select ICs. We're going to put in the device M27C512. That's the chip that's in the Fadal here. It's made by ST, and it is the DIP28 form factor of the MC27C512. Going to select that. At this point, we can go to Device and Read. You'll see MC27C512, how it's supposed to be arranged in the socket, just like we did earlier, and then we're going to read it. Cancel. At this point, we've got our binary file read into this window here. It's all very simple. You don't have to change any other settings here. I'm going to go to File, Save, and here we can save this binary file. So I've got these saved as essentially what they are stamped with on the top. Once we have them saved, you should put this in like a Google Drive or whatever to keep them safe. If we want to load up one of these binary files into a new chip, we pop the new chip in the exact same way. We'll go to File, Open. We'll open up whatever binary file we want to flash. So we'll open that up. This is all default. And then we'll go to Device, Program. And then we'll hit Program. So I don't have a blank one in there right now. I just have the one we just read. Once we do that, we can verify it. So we can go to Device, Verify, and then click this. If the binary file that we loaded up matches what's in the chip here, then it should say Verify Finished. If we've got some kind of error or something, so let's say I'm loading let me pull up like this rigid tap binary. So if we were to have written a file and we wanted to verify that what's on the chip is correct, and then we hit this and we get these messages, that means that the memory is different, um, or there's some kind of error. Uh, for the most part, this is pretty foolproof. Um, so I'm just going to reopen this one, and then you'll see that this binary matches exactly what's on the chip. Everything's happy, and that's all we need to do. So basically, just select the IC we want to program, then go to device, and we're either going to read and read it, or we're going to program and program it, and then we can verify what's on the chip matches what's in this binary file. It's all very simple. So that's all you got to do. None of these other settings I changed. All I did was select the IC and then, uh, save the file. So that's it. And once you've got these binary files, you can zip them up or, you know, do whatever you need to do to them to keep them safe. But yeah, it's very handy to have these things because if you were to go to, um, ITS or any of the other suppliers for Fadal parts, you'll see that these things are actually quite expensive if you have to replace one. So it's good to have a backup. The actual access control card uh, is kind of universal, so that at least on the 1010 6 cards, you can basically just like move a jumper around to tell it uh, what it's going to be programmed to do, whether it's a x-axis or a b-axis or a spindle or whatever. And there's like a little uh, table that shows you where all the jumpers need to be. The important thing is that you've got the correct EPROMs slotted up, um, so that the card actually knows what it's supposed to do. So that's it. Yeah, we're just gonna save our binary files just in case something happens to the card, it gets fried. Somebody loses it, gets crunched or whatever happens. Drop something on it. Who knows? Whatever happens, at least you'll have a backup somewhere. So some of these chips are like $800 plus to replace. So, and the supply is dwindling, I'm sure, because nobody makes these anymore, I don't think. So basically, do yourself a favor and save these binaries just in case.